so time to reconvene again. So it is my pleasure to present Kian Salimkhani, who will speak about turning space-time philosophy right side again. Thank you.
Thank you very much, Amelia, and thanks for having me. So this is what I would present today is what Niels praised as a morally wrong paper. And to make it even worse, I chose the really controversial title. There is also a less controversial title, which is the actual title of the paper. The many problems of space-time emergence in quantum gravity, and this is work done in collaboration with Rasmus Hjortsland. So recall that we have had this debate on the fate of space-time and quantum gravity for quite some time now, and in one of the seminal papers by Nick and Chris, we find, for example, this sentence: as far as many quantum theories of gravity are concerned, in various ways, familiar spacetime is not admitted at the fundamental level. And one of the original motivations to start this project was to put emphasis again on these words "in various ways," because we think that this is partly overlooked at least. Why do we think that? Well, the philosophical literature can sometimes give the impression that space-time emergence is unanimous in quantum gravity research, that it's a single and special philosophical problem, and a problem that can be approached in the abstract. And we think that because it's often phrased as the problem of space-time emergence, and then there is sometimes some clarification what that means, sometimes there's less of clarification what that means. This is not to put anyone here in the spotlight, but those are typical ways that we find this. So actually I put them in again because yesterday I thought maybe I shouldn't put up your names, but I mean, I've done this myself, so yeah. The problem of space-time emergence in the philosophy of quantum gravity, or how is it that non-spatial polar entities and properties conspire to produce spatial and polar ones? Just abstractly, just generally. Now, our main points are basically, space-time is the wrong level of abstraction for dealing with the very specific philosophical issues we are facing in philosophy of quantum gravity. We think that quantum gravity raises many different, interesting philosophical questions, and this is partly because there are different quantum gravity theories. This is basically Nick and Chris' point. So it raises these different philosophical questions for different theories, but also for different spatial and polar aspects, and potentially also across theories. Important is that these spatial and polar aspects are what defines basically the problem or the problems. So abstract investigations don't help in this situation, we think. For example, it hinders an assessment of which problems are more crucial, so also related to that, which attempts to solve these problems are probably more important at least. And what is precisely at issue for general philosophical problems like what is the fate of human metaphysics in the light of quantum gravity. And we can translate this into two claims, basically, one weak claim and one strong claim. The weak claim would be that you just explicate what you mean by space-time. And this should be done in terms of concrete spatial and polar aspects. For example, metric, dimensionality, topological structure, and so on and so forth. And the stronger claim is that there is actually no such thing as the problem of space-time emergence. And in the paper, we then also discuss possible objections to this stronger claim. So what if you want to defend abstract talk about the problem of space-time emergence? Well, you can think that there is only one philosophically interesting problem actually at issue, and this arises when spatial and polar aspects of some kind are emergent. I will talk about this in more detail soon. against this, we basically say, against the singularity objection, we say, well, there are different, very different problems, philosophical problems. So this is kind of our argument against the singularity objection. Then you can also think that, well, okay, there are many problems, but they share a common core. That would be the commonality objection, and we basically argue that we don't see a common core, to put it, mildly. And the exceptionality objection would go like, well, there are several problems, but one stands out. Maybe a few of them stand out. And we don't think that there's actually such a problem that stands out. Maybe just generally, so we think this issue is addressed by just showing that there are several interesting philosophical problems. These two are not argued for in completeness, but it's that we think at the moment we don't see how this would work out. So this is one way to make ourselves more understandable. If you can come up with a way how this could actually work, then we're fine with it, I guess. At least I would be fine with it. But I think Rasmus as well. Okay, so here's the outline. I will just briefly mention what space-time emergence talk in quantum gravity looks like in physics and philosophy. Then the debate on what counts as space-time, because another motivating part of this was to see that space-time is already an ambiguous notion in GR, for example. Then, the core of the paper, the many problems of space-time emergence, and also some comments on what general philosophical problems would profit from a more fine-grained perspective on this. I don't want to talk about this in too much detail, but we kind of start out the paper by comparing physics and philosophy, and if you do that, I won't go through it, but you see, well, it seems to be rather similar. So both talk about space-time emergence to some extent. However, if you look more closely into the literature, then into these papers actually, then you find that in physics you usually also find specification of what space-time is supposed to mean. So you find that Sindoni, for example, is interested in Lorentzian signature and how this can emerge in certain condensed matter systems. Faulkner et al. Show how the linearized quantum vacuum Einstein field equations are dual to a constraint on entanglement in a conformal field theory, on Minkowski space-time, and so on and so forth. So they say quite a bit on what they actually address as space-time emergence. So you could say it's just gloss, in a sense. It's defining a discipline, but it's more or less superfluous gloss. And this specificity, we think, is at least less common in philosophy. You obviously also find such works, but it's just less common. And especially if you move out of our subdiscipline, so to speak, of philosophy of quantum gravity, you find people discussing the fate of priority monism or Humean metaphysics, and the background is the non-fundamentality of space-time, full stop. And that, we think, might be a problem. So, should put it there. It seems to be a rather trivial point that if you want to investigate the problem of space-time emergence, you should clarify the notions that you use. You should clarify, amongst others, the notion of space-time. And then, so this is crucial as kind of common sense. But if you look now in the literature, you find, for example, a minimal definition in terms of the space-time of GR, and then we think you didn't solve any problem because space-time of GR is still ambiguous. You have the geometrical, the dynamical view. You have certain views of functionalism on space-time that differentiate between. So there's actually disagreement about when space-time applies in a certain theory. Is there as a fundamental feature of some theory. And now our initial observation that there is disagreement about when space-time emerges in some theory, we think is evidence of the fact that also the what question is probably, there's also disagreement about this. So what is the problem of space-time emergence is as well debated, if you disagree on what this is. Yeah, so basically, this is just to say again, it may be taken as a trivial point, and if you agree that explication is necessary, then we basically only have two minor points. First, if space-time is analyzed in terms of two or more spatial and polar aspects, for example, manifold and metric structure, then please also explicate whether an investigation concerns both or just one of them. And if you have more, of course, the same applies. And also recognize that there are interesting other problems and questions that are also raised in this context. So, in a sense, at least the weak version, and if you agree that you should be specifying what you're talking about, is just, okay, then please also say that you're talking about metric and manifold and not space-time. However, we think that this abstract talk is arguably deliberate in many papers. And then again, we see these three ways to defend this abstract talk. Just briefly again, the singularity objection states there is only one philosophically interesting issue that arises when spatial temporal aspects are emergent. The content of this problem of space-time emergence is sufficiently well specified, even if it is ambiguous when precisely the problem arises. So basically, there is this objection also implied to our inference from when disagreement to what disagreement. The commonality objection again says there might be a general or overarching problem of space-time emergent, and this one is sufficiently independent of the details of the various approaches, and therefore we can have this common core debate here. And the exceptionality objection recognizes actually, or at least you can do so, that there are different spatial and polar aspects that you can have emerging, that there are many problems. Same is, of course, the case for the commonality objection. But just one stands out. And this could, for example, be accompanied by a debate on the essence of space-time in a sense. So often people who are interested in what is the essence of space-time would, if they are also interested in the problem of space-time emergence, then this would be one way they could go. Yeah, maybe just on this. So if you have this objection, then you already agree that you need to be very specific, because also this essence of space-time debate is then very specific. You need to define what exactly is the essence. And then this can be understood as a rather weak objection that seems to maybe vindicate the legitimacy of still talking about the space-time emergence in abstract terms, but maybe you shouldn't do this because you're already on board in a sense in the broader picture. Now, these three objections kind of translate or have something to say on different concepts of space-time as in broader terms. And we discuss we discuss 5 different conceptions of space-time in the paper, and they then also reflect different understandings of the problem that you have. So I will not go through everything here, but for example, you can have a very thick understanding of what space-time means, and that the understanding of space-time that you have is then that all spatial temporal aspects are individually necessary for space-time. So only if you have all the spatial temporal aspects that you that we know of, or maybe even more, as fundamental in your theory, only then only then you have space-time present as fundamental in your theory. And if just one is missing, and it doesn't matter which one, you don't have spacetime as fundamental, and you have a problem of spacetime emergence, so to speak. So this is how this then translates to this understanding of the problem you face. And if you have this understanding, then you have actually an understanding of the problem of spacetime emergence and a potential defense of this problem of spacetime emergence talk that is close to this commonality objection, because you think that this problem is shared by all these various versions of how spacetime may emerge by just one aspect emerging, where you don't specify this. And yeah, you can do this for a thin understanding. For example, the thin understanding would be that any spatial and polar aspect is sufficient for spacetime being fundamental. So you have your list of, you have your analysis of what spacetime is, you have your spatial and polar aspects, and if just one of those things is fundamental in your theory, then spacetime is not emerging. But if none of them are fundamental, and then one is sufficient to raise the problem of spacetime emergence, and this is then close to this exceptional case, or exceptional understanding of spacetime emergence. Yeah, basically I said, I think this here, yeah, both things. So now, what are the many problems of spacetime emergence, or what do we mean by this? So this is arguing against the view that there is one single problem of spacetime emergence, and we think that having dimensionality emerging, having Lorentz signature emerging, having the metric, having topological structure emerging, this is very different. You have very different problems arising. You have very different theories also sometimes that address these issues. For example, emergent dimensionality opens a discussion about the meaning of dimension, and emergent metric could potentially challenge versions of this Humean metaphysics or Schaffer's priority monism. Or at least Schaffer's individual spatial and polar individuation principle, and so on and so forth. So, yeah. The issue is, for every spatial and polar aspect, you have certain problems that come with it, you have certain issues that you address in the physics, you have certain issues that you can address in the philosophy. And these can be very general. So if you have a space-time split emerging, then you can have a debate on what time is exactly, how it differs from space, what you need for this, and so on, also in the philosophy, very generally. Now, let's assume that this list that can go on, we discuss, I think, these, maybe one more example in the paper. Let's assume this addresses this singularity objection, and actually this is off the table. Then you have still two options for defending this abstract talk, namely the exceptionality and the commonality objection. So is there any exceptional overarching problem? And we think that if you look at the cases we present, then you recognize quite some diversity of what you are talking about there. And this diversity challenges the claim that there is something that is common to all of them. That at least addresses the common core objection already. Now, as I mentioned, we don't have defeating reasons against them, but we don't see any compelling reason to think that the two objections go through. So more carefully on the overarching problem. So is there an overarching problem? Does the commonality objection work? The general problem here is that you then have various spatial and polar aspects emerging, and they pose very different problems, but somehow something permeates all those cases. Some problem permeates all those cases. And especially the thick and the cluster construal, which I didn't talk about, could argue this way. And well, if you look at the details, then you think, well, the differences between the specific problems and also that these problems seem to be independent to quite some extent. So it's rather independent having dimensionality emerging than having metric structure emerging or something. This raises a problem for this view that there is an overarching problem, and places the burden of proof, at least, on those who want to think that this is the case. So here's something to think about to make sense of this, what I just said, and also the exceptionality objection in a different light. So this is some just hypothetical theories are filled in here. We just take the number of non-fundamental spatial dipole aspects. So if we have everything is fundamental, basically we have, let's say, GR could be a candidate for this, if you want to restrict yourself to spacetime being GR spacetime. And then you can have one spatial dipole aspect emerging, the spacetime split, for example, the metric, dimension, and so on and so forth. Maybe then you have theories where two of those spatial dipole aspects are emergent, and so on and so forth. And if you have n spatial dipole aspects, then at this level you have everything as non-fundamental as emerging in the theory. Now you can phrase the challenge of commonality alternatively for the thick version now, for the thick understanding of space-time. Consider the problems raised by the emergent metric cell in row 1 here, versus the difference between the problems raised by the emergent dimensionality dimensionality cell in row 1 and the emergent dimensionality and metric cell in row 2. Right? In both cases, the philosophical issues relate to an emergent emergent metric. But in one, the thick construal will have it that the problem of space-time is added on top. So there is supposed to be a qualitative difference between the two things, where the difference is apparently only in that metric structure is also emerging. So the challenge is now to all of you, what is this, if you want to defend abstract talk, what is this qualitative difference here between moving from row 0 to 1 as compared to moving from 1 to 2? And to address also the exceptionality problem, there is this table is particularly useful to do that as well, because we are now talking about everything is emergent. So the problem of spacetime emergence arises when moving from row n, where everything is emergent, to row n minus 1, where one spatial dipole aspect is fundamental. And one would then have to show that, say, adding emergent split to the case where all spatial dipole aspects but split are already emergent is generating a qualitatively different problem as compared to the problems arising when adding emergent split to, say, emergent metric. So it's again the same kind of argument, but now addressing the exceptionality problem. Yeah. So what is the general relevance of all of this for philosophy? We think that there is quite some relevance to this. First thing you can notice, and Nick and Chris already did notice this, space-time emergence is very different in different theories of quantum gravity. So this makes the case, and they make the case, you should consider theories for themselves and discuss those theories in detail for themselves. And now the interesting thing, what we would add now to this is that this specificity in terms of theories is actually parasitic on the spatial dipole aspect talk. We shouldn't discuss theories in their own right, and we shouldn't discuss the different theories as separately, basically, not just because they're different theories, and we always do this in philosophy and some other reason, but because the relevant spatial dipole aspects are different in those theories generally. this is not an additional issue, it's the core issue, basically. So what follows from that is that theory-independent research is still possible for us as philosophers that are interested in this kind of thing. And the second thing I want to mention is that there are, as I already did mention, there are these more general philosophical problems that mention the non-fundamentality of space-time, don't discuss it, but then apply it, so to speak. And we think that this is highly relevant for such endeavors because we basically want to have clarification of precisely which spatial-temporal aspect is crucial for these cases. So if you're interested in humanism and say, space-time is emergent, so maybe humanism doesn't work. What would be way more fruitful and way more open to making progress on this issue is to, for example, state, well, do we need a fundamental metric for humanism to make sense? For example, relating to the fact that humanism usually, at least in the traditional version, uses distance relations as world-making relations. Or priority monism, what is actually the problem for priority monism? So the view that you have a whole, the universe as a whole, and then that's the fundamental aspect, and then everything else is derived from that. What is actually the problem when space-time is emergent? Is it a problem when the metric is emergent? Maybe not, because you may only need that there is a certain wholeness to this thing, so maybe manifold structure suffices. Maybe some adjacency structure that permeates all of, the whole thing suffices. And then the problem only arises if that is not fundamental. Similarly, if you're interested in demarcating causation and grounding, there are these proposals that are on the, we have a spatial-temporal demarcation criterion. But what exactly is needed here? Is it time? Is it time direction? Is it what exactly is is doing the work in demarcating grounding from causation? Similarly, for example, if you think that closed time-like curves pose a problem to having time as fundamental, maybe it would be more helpful to discuss this, and it has been discussed, of course, exactly in those terms, whether it's a problem for directionality of time, whether it's a problem for the order, the time order, and so on and so forth. Okay, to conclude, modern physics is said to raise the problem of space-time emergence. And this abstract phrasing, we think, is problematic because it is ambiguous what space-time means. And the different construals of space-time then also result in different alleged problems of space-time emergence. And this is, we think, important to discuss in more detail. And the different theories, of course, also don't hint at any shared or exceptional problem. And also, if you look at the different specific problems that can be traced back to different spatial-temporal aspects emerging, this also doesn't show any shared or exceptional problem, we think. And this is very important for general philosophical investigations, and therefore we think that referring to these problems in the abstract as the problem of space-time emergence is a problem, and we should discontinue it. Yeah, thanks.
So thank you, Kian. Now we have Jessica's comments.
Thank you. I really enjoyed this paper, and I think that it's really timely to be asking these questions right now. So maybe I would just capture the key points so I can kind of separate the thing that I think maybe also should be focused on. So you're kind of saying that philosophers that are working on, well, philosophers who are working on the emergence of space-time are working at a level that's kind of too abstract, such that space-time and what space-time is too ambiguous, that we can't have a unified or coherent debate about how it emerges. There's no single special problem. There are these different aspects, different spatio-temporal aspects that are emerging from different theories of quantum gravity, and this is giving rise to like a bunch of different problems. They have nothing in common, and none of them are sort of more philosophically interesting than any of the others, and the abstract discussions are missing this. And so what we should do is kind of discontinue these general projects of providing models of the emergence of space-time in general from a non-spatio-temporal level of reality. And we should only frame the problem in terms of these very specific spatio-temporal aspects. And so I think that this positive proposal to do this specific project is really valuable. I don't think that that's particularly controversial. I think that there is some utility in providing these general models, and so that's what I want to think about. And I'd like to kind of respond by just thinking about some of the motivations for ruling out this general project, and maybe make a little bit of a defense of its value. So one thing I think is that the general project has contributed to kind of being in a position to have the luxury of doing a specific project now. You might think that the general project is like a necessary step in providing a conceptual framework, the kinds of tools that we need to actually undertake this specific project. It might even be the case that your argument is a little bit undermined if you think that you can totally rule out the general project, because you will need, presumably, some of the tools that you get from general models to model the emergence of these specific spatio-temporal aspects. And so I think because the specific project is kind of based on some of the general models that we've seen in literature, like models in terms of notions like composition and parthood, models in terms of functionalism, you kind of needed those to get maybe the specific project or specific models off the ground. So I think we need to specify the project at the highest level of generality so that we can be in a position to do maybe the kind of work that we need to do now to make progress. I'd also like to know more about the motivation for the physics first approach that's here. So I think your claim that metaphysics needs to operate at the same level of specificity as physics in order to do any valuable explanatory work maybe needs a little bit more of an argument. It's not clear why maybe we should choose this kind of physics first approach, why we should think that it's up to physics to dictate the right level of specificity in explicating this problem, rather than thinking that metaphysics and physics are kind of engaging in a shared project here. And so maybe we need an argument for why that's better, or at least a criteria by which we might choose the right level of specificity to address this problem. I'd also like to know a little bit more why you think that the general models are a bit broken. So what is it that they fail to do, and do they really fail to do any explanatory work? They might not be able to, we might not be able to transfer some of the implications from those general models to the specific project, but you still might think that they give you some broad explanatory framework. So maybe a weaker claim is that we need to do the specific project now in order to make some progress, right? That's where we should focus, but it's not clear exactly why you think the general models are explanatorily idle. So I think if we're kind of to buy this full package about how we ought to approach the emergence of space-time or specific spatio-temporal aspects, then maybe we need to hear a little more about why physics is dictating this level of specificity, why you think that you could undertake the specific project without any of the general models that have been provided, and also why you think there's just no explanatory work at all to be done by general models, for instance, by providing maybe like how possibly explanations, or even just providing the general framework so that you can take that and use it in some cases, right? For some, the emergence of some specific spatio-temporal aspects, you might think that composition is useful, and others it might not be. Maybe you think functionalism is right for some, but at least the general model will show you, how you can make use of those tools in any of those cases.
Yeah, many thanks, Jess. Very good comment. So maybe to briefly say something about this. Physics first. I think Rasmus and I have different views on this. So if you want to have a defense of the physics first approach, you maybe should ask him. I think there is still a sense in which physics might dictate where we have to look. But that then would concern more generally the question, what is the relationship between science and metaphysics? I would be sympathetic to a view where metaphysics should not only not contradict scientific findings, but also be kind of the afterthought to scientific endeavors. So in this sense, yeah, maybe physics should be first in defining these issues, but I don't think that necessarily physics dictates us, what kind of questions we can ask in this debate. So I think it's perfectly fine to have a philosopher asking for the first time a certain question about in this realm of spatial and temporal aspects emerging, and this is because I think that what is really at issue here is that we need the specificity in defining what we are actually talking about, and not so much because the physicists work on these specific topics and then we come and discuss our philosophical things about it. But yeah, what did I want to say? What was another question? What, right. So I think you're right. You might be right that at some point it was useful to just talk about this generally, and now maybe we need to go a step further and be more specific. And this can be made plausible from the point of view that historically, traditionally, we have this divide between meta and space-time, and there come various debates with it. But now we discover that actually, or even without physics, I would say, if you have these debates, like for example about consciousness or something also, which we mentioned in the papers, maybe broken analogy, but anyways, when you come up with this idea, well, there might be a problem about consciousness, there might be a problem about space-time emerging from some meta theory or so. And then you think about it, and then you find, well, actually I have to make certain distinctions to make sense of this claim. And in some cases, I can say, well, yeah, there is actually a problem, and in other cases, there is no actual problem. If you have a specific understanding of consciousness, and then you have specific premises that immediately support this understanding of consciousness, then, well, there's no problem. That's fine. So yeah, the general usefulness of these general models is maybe there, but maybe we now have to do something else. Yeah. There was a third question, I think.
Yeah, I guess I was wondering, I'd like to hear more about why you think some of the existing models are not doing any.
Yeah.
Like what is particularly wrong in virtue of them being in virtue of them being too general and not specific enough? What is it that's wrong with the causal mereological model of space-time emergence, or a functionalist model of space-time emergence?
Yeah.
That is at this general level, right? Because I think that the same tools that you will take from those models will just be the ones that you will, take to your specific models as well. And at least then maybe we know how they work if we have some general framework.
Yeah, I think so. I'm skeptical whether they can actually do the work needed to support the claims they then make. If you want to understand, for example, time and certain causal modeling of time, then I think if what you actually, I mean, to some extent they actually do it, of course. But if you want to make that claim, then you will have to define more precisely what parts of time you're talking about. And especially if you're concerned with questions of fundamentality, you have to answer whether the directionality is fundamental, or whether you have some order being fundamental. And yeah, you're right probably that you can do it to some extent. In this sense, we might be complaining about that people don't do it often enough. On the other hand, I think, I mean, yeah, you're right. I mean, we wouldn't necessarily use different modeling proposals. We would just want to have more specific adjustments, more specific adaptation of these models, so to speak. And if you talk to people who do this, then they usually they agree, yeah, right, I mean this and that, and so on and so forth. But if you then move out of our subdiscipline, then you sometimes find these people that, know that space-time is debated as non-fundamental. Oh, maybe I can apply this to my favorite metaphysical theory. And then they don't have this overview on what are the details. May there actually be cases of non-fundamental spatial and polar aspects that can still work with their favorite theory. Yeah, but there is some moderation happening now, you see.
So let's open the floor to questions. Okay, so then, Chris?
Thanks. So maybe you've already conceded quite a bit to chess, I'm not sure. But I would like to push a bit more, I guess, without denying, of course, the interest and relevance of specific questions that specify, in various ways, the problems, make it more specific. I really don't see what's wrong with asking questions like, or considering arguments of the form, metaphysical theory M presupposes the fundamental existence of space-time. Quantum gravity suggests space-time may not be fundamental. Therefore, advocates of theory M might be well advised to revise or generalize their theories such that they do not rely on the fundamental existence of space-time. Or space-time might be a necessary condition for there to be empirical confirmation. Theory T does not posit the existence of space-time. Therefore, theory T might actually deny a condition necessary for its empirical confirmation. Now, in any of these arguments, it doesn't really matter what we put in as space-time, how we specify space-time. No, the arguments are valid if they are, as long as we don't equivocate, of course, meaning, referring to space-time with something else, something in line 1, and then the second verse is something else. It could refer to pink elephants as far as the validity of the arguments is concerned. So I don't see why there's not some value in considering these very general problems for which it doesn't seem to matter what exactly space-time is. None of this, of course, rejects that there is interest and relevance to maybe then look at specifically what happens if the metric is not fundamental, if this is not fundamental, and so on and so forth.
So, right. But so how I would understand this is as follows. So you basically, I think, then suggest there could be a first step, having such an argument, and then Erasmus comes along, or I come along, and say, well, your first premise there is actually wrong, or I don't understand your premise. Please fill in something else. And you have to revise your argument, and then you are at a more specific argument. and we think this is the actually useful argument. This is what we can work with properly, where we can actually, because we know so much already in a sense, and that kind of is why, yeah, maybe there's actually, there has been at some point value to these more general issues. But now we know that there are various different spatial temporal aspects that they inflict various many different problems, and those problems address issues for certain metaphysical theories, but for others they are completely fine, and so on. So I think, yes, the argument you presented is as such valid, but it's you will immediately come up with, well, there's actually some problem. This is not specific.
I mean, the truth of the premises of these arguments will depend on what, of course, we mean with space-time, and therefore the soundness of the arguments will depend on that. But there's a sense in which philosophy of quantum gravity is speculative. We are thinking about various sorts of arguments where we don't know whether the premises are going to be true or not.
But as I mean, still, even if it's speculative, whether the argument actually goes through, whether you're actually arriving at a true statement at the end, will be different for what you fill in for space-time here. So that's why we think it's more helpful. It's just making more progress if you are specific to a degree that is fruitful, because that is also, of course, something you can argue that how specific do I have to be. And Niels rightly pointed this out at some point when we discussed this. So we would say be as specific as is fruitful, which also addresses somehow your observation that maybe there was a time where certain specificity was enough, and then there is a time where you need more specificity in a sense, because it's then more useful, more fruitful. Yeah.
Then Baptiste.
Right. Thank you. So let me start with the part I agree with. I think you're absolutely right that we need to focus on the specific features, and those are important. But I also feel it was a bit of a missed opportunity to be so dismissive of what had been done before and confrontational, in the sense that I think part of the paper is targeting a straw man, if the idea is to say that it's not sufficient to stay at the general level of description. I think that's correct. That's not sufficient for all purposes. Ideally, we need to have to provide all the details. But then, of course, there is this question about the level of generality. So I also think it's necessary. So maybe it's why you disagree about. Although you conceded quite a bit to Jess, and I think I agree with everything you said. And yeah, I think in a way, as Jess said, it's to complain about this general level is a bit of a luxury in some sense, because when I studied, for instance, we had this all those results like issues with disorder locality, quantum gravity, issues with the metric in string theory or different approaches, and basically that was kind of we're trying to find some points of reference to start doing some conceptual engineering, abstracting away, trying to identify what are the common issues, what's puzzling. So I think at this stage I was really needed to abstract away from the diversity of different approaches and try to find some common, something common to all the different approaches. And for instance, you say like people are talking about the problem of space-time emergence, but I mean we do that sometimes, but also because we take for granted the fine-grained discussions of different approaches. So for example, take my synthesis paper. Basically I'm not talking about the different features of space-time that may come under threat, under attack. But the reason I'm why I do that, I'm holding this fixed, is because I'm trying to distinguish between different conceptual issues, right? So because I'm focusing on articulating all the different conceptual issues, I mean, I cannot really talk at the same time of the other parameter, which is what are the different features of space-time that are denied reality or fundamentality. But I think there is a kind of natural reason to do that. That when you are building some part of the space of options, you have to hold fix all the things, right? And I think a lot of the quotes you gave, it's because I was, at least my case, about holding this fixed, but of course I was aware that there were different features of space and they were under attack in different approaches. And I completely agree with you that depending on which feature, the result might not be the same. So like for priority monism, if it's the metric or the manifold or whatever. So I agree with that. But we're really trying to do some conceptual engineering. We're starting from scratch, trying to build something. So I think it was a necessary step. Although I agree with you that it was just a step, ideally.
Yeah, thanks. No, that's a good point. I mean, maybe what helps to order this this debate and the different remarks is what is the heuristical value of doing certain
exactly.
things.
Even if you think there is no non-heuristic values, I think you cannot deny there was heuristic value.
And on the other hand, from like looking back, what did we do? What have we done on these issues? What would be the best way to express these different problems that we faced? And so the paper is arguably more in this looking back kind of perspective. So the idea is there is lots of work that has been done, and I think we don't neglect this in the paper. I mean, we certainly know that this is useful and very important work. That's why we cited it. But it is looking back. There are these remaining issues that you address by being more specific then, right? So that would be one thing. And I wanted to say something. Again, on this issue that there is maybe a common core problem or something, which you again kind of mentioned briefly.
Or multiplicity of common issues.
Yeah. We are completely open that there is such a thing, and we want to have this presented basically in the ongoing debate then. So maybe there, as I mentioned, the argument against the commonality objection and the exceptionality objection, they are not arguments that are sufficiently well argued for. It's basically an observation that we don't find anything in defense of these characteristics, commonality and exceptionality. And this kind of also, this strongly relates to this debate on what is the essence of space-time, which is completely fine for us to have this debate. Basically, you just then will have to say which kind of spatial temporal aspects concretely define this essence of the spatial temporal, and in comparison to meta, for example. And this is an ongoing debate at the moment, right? People like Niels Martens attack this distinction and say we should have like a different way to address these issues. There is not like meta theories and space-time theories. There is nothing like that is 100% meta, or maybe there is something that is 100% meta and 100% space-time. At least at some point they had this view, but there's lots of things in between that share features among these across these different camps. But this is fine for us because essentially this is fine because you acknowledge that it should be about more specific differentiations here, and then you have this coarse graining into meta and somehow related to space-time stuff. But I hope I addressed your question.
So So I mean, some I also have a paper called Spacetime Quietism, when we go in that direction, saying that there is no general agreement on what spacetime is supposed to be already in GR.
Yeah, yeah.
So, I mean, well, yeah, we're very friendly to this.
Yeah, yeah.
Thank you.
Thanks.
Right, then we have Sam.
I want to push a little bit harder, I think. So I don't really want to concede the idea that the general thing is just a step along the road to the specific thing. I think there's like interesting work to be done with the general thing. I don't think there is like, I don't want to put my hand up for saying that there is the problem of space-time emergence, but I think there is a problem at a higher level of generality. And that's because there are some sorts of things that don't seem to depend on what space-time is, what features it has. Because the sort of metaphysics has been done at the same level of generality. And so when you try and sort of build certain kinds of models using existing metaphysical tools, you get into trouble because the two levels of generality sort of like coinciding. So because I was in a table, I feel compelled to defend myself.
Sure.
The sort of mereological stuff, the issue there is that like if you look at how people have like written down axioms for mereology or written down proofs of mereology, what they've done is they've said things like parts have to have the same spatiotemporal locations as their wholes, right? If spacetime's not fundamental, it looks like those mereological claims are just like in trouble, at least on the face of it, right? And it doesn't really matter what spacetime is. And this is sort of the kind of direction that Chris was going in, where you can formulate these arguments. But I would even resist the idea that you need to go any more specific just to see that there is at least some conflict between the way that metaphysicians think about mereology, the idea that spacetime is not fundamental, and then trying to like bring spacetime and mereology together as like your model of thinking about the way that whatever is in GR connects to whatever is in some more fundamental theory, right?
But thanks. It's totally fair that you push me on this, of course. And that was part of the reason why I wanted to present it here, because I know that I would make everyone upset by this, yes. So it's good to have discussions and progress on my side as well. But wouldn't you say that if you talk about this mereology stuff, it's so, for example, dimensionality is out of the picture. It doesn't really depend on what kind of dimensionality, what type of dimensionality you have, how many you have of them, and so on and so forth. So it's a more specific problem, and maybe you can point out what exactly the problem is. What you can say more concretely what feature of space-time allows for this distinguishing different localities, distinguishing whether they coincide, and so on and so forth. And this seems to be rather independent also of metrical features, maybe. It's more about certain, maybe something about topology that helps to make this more precise, certain features about what kind of adjacencies you find and what you don't find. And so this is what I mean, that where you still have progress by being more specific even in such cases, because I think just generally space-time is not doing the work there. It's a very specific part of space-time that is crucial for these kinds of distinctions.
That's the thing I'm resisting. So I do agree that like doing the more specific thing is like can make more progress. Yeah. But like the thought is that space-time gives you locations in the sense that mereology sort of uses them, at least the way that metaphysicians have developed mereology for physical objects.
Yeah, okay, I see. Yeah.
And now it just looks like you've got to revise mereology, because if you're thinking that mereology works to connect the levels in some way, well, the way that metaphysicians have designed it presupposes a background space-time. I mean, this is the sort of thing that Chris was pointing to with like, but maybe a different kind of cases.
Yeah, I have to think about what my assumptions are here. Maybe I have to revise some. Yeah, I have to think about it. Thanks. Yeah.
So, it's a finger? Okay.
So I was wondering whether you could say something like you could distinguish between a project which is more internal the philosophy of quantum gravity, and then try to defend why you defend it. But still admit that for other projects that are not internal to the philosophy of quantum gravity, there it's very important to have the level of generality, even though in the philosophy of quantum gravity there may be more like a step towards a more complete. There would be an attempt to try to incorporate, and I mean you will have to accept that there is some interesting explanatory work to be done by the general level, but that will still be consistent with the spirit of what you were trying to articulate, I think.
I'm thinking about, so is the reasoning that there is a certain, maybe you don't have to talk about traditions, but there is a certain tradition where you use space-time as a fundamental concept, and then you apply that fundamental concept in like generally also more abstract reasoning. Yes, but then you kind of so I could go for the easy route maybe and say, well, this is maybe a problem of how we came to use these kinds of theories, how we invented them, because we didn't know more concrete notions of certain adjacency, certain topological structure. Instead of this, we used like this more these older notions like spatial and pole space-time. So it's a contingent fact about how we came across these theories, maybe. But I have to think about whether that's actually a good reply. Yeah, but thanks.
All right. So for previously conquered priority, it's Lorenzo now.
Right. So I will come to your defense.
Finally, thanks.
In part because I appreciate the fellow provocateur. So it seems to me that, you know, I've said many times that to some degree the story of space-time disappearance seems like false advertisement, in the sense that it seems crazy, but I mean in some version it doesn't seem to be that radical. But if I understand your claim is, when we want to evaluate the implication of that, especially for metaphysics, which would be, if I may say, some today's theme, what space-time means and what disappearance means really matter a lot. And to me that seems to be obviously right. So I think, if you take, suppose you're interested in something random, I don't know, you want to do, say, Fritz program beyond space-time.
Some people are working on this, yeah.
It seems pretty obvious that normally the way you do it, you rely on space-time in a lot of ways, especially to have a space of quality which is really large. Now, if you're moving, disappearance means we move to a discrete space-time, which is one of the possible scenarios, then there it looks like you're in trouble. At least prima facie, it seems you lose something. If you're in the case of string theory, and then you have some other fundamental space, which also has all of the same properties, it just has many of the same properties, maybe just higher dimension or something like that, then there is no problem for this program. You're just as happy camper as you were before. I think also Sam's example of mereology strikes me as a good example of why you're right, actually. So, if, to take your example, we have the manifold, so the topology remains the same, it's fundamental, and what is emergent is the metric. There is no problem for the usual heuristic for mereology that I can see of.
Yeah.
It's only if space-time really disappears in a radical sense that the sort of heuristic, that spatial heuristic that is sometimes given gets in trouble. So these, I mean, it seems to me when you go to concrete examples, what your point is undeniable.
Thanks. I don't know whether it's undeniable. It's obviously not undeniable.
Deniable. Barely deniable.
No, but thanks. I mean, yeah, this is the idea, and now my feeling is that it has to do something with these traditions of thinking about certain problems. But if you like throw away everything and you just look on the results you obtained, and now you try to make sense of them, then I think the best way to make sense of those, especially also mereology, is to be more specific than you were previously for those reasons. And you also give me the chance to once again say there is this positive proposal, and the negative argument that there is no such thing as the problem of space-time emergence that kind of is then following. This is still open to debate. We laid out how you could reject our proposal here, our argument, and you have to show where you actually need the generality. And I'm still a bit skeptical whether you need it, for example, for mereology, but yeah, I still have to think about this. Yeah, but thanks. Yeah.
Right, then we have Renata.
Yes, okay. So as a practicing quantum gravitator, it will not surprise that I have a more specific view.
Yeah.
Okay. So I think you raised some really good points. So I would say emergence of space-time, I would say, has a bad name just because, especially for this emergence that has been used in physics in such a hand-waving way, mostly to express, I have my favorite dream of, quantum gravity of space-time, beyond the Planck scale, the Planck scale, is my favorite little blah 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 bits or something. And I have an intense wish that from it may space-time as we know it emerge. So that's a very strong motivation, but of course, details about this should happen, and it turns out to be very, very difficult. You're pointing the finger on the space-time bit, which I think is equally important in what we mean by space-time, and it's also being used very loosely in physicist circles, like as in space-time as we know it. But what do you mean? G mu nu? Mostly people mean G mu nu. So coming from a non-perturbative angle, I think trying to reproduce G mu nu, which is simply an element of a classical theory, is just not the right thing to do, and it cannot be done, I think.
Yeah.
But there is middle ground, and kind of you were grasping for it, where I say, okay, so if it's a not remaining or pseudo-remaining geometry, what should it be then, right? So, because you want to make it quantitative, right? It should be still a theory of whatever, quantum space-time, for want of a better word, right? From which then, what we in the old days we always call the classical limit. So we never called it the emergence of space-time, but people working on non-perturbative quantum gravity said, we have this terrible problem, it's a classical limit. No one was talking about emergence of space-time anyway, because it's very hazy notion. So, and then you're very soon led to the question of what are the observables? So, and here I think things start being more specific than just, generalities, and it doesn't really mean what we mean by space-time. Because these observables were, in a technical sense of being, the invariant diffeomorphism invariant quantities, that it turns out continue to have a meaning beyond just purely classical. These are very special. They're these non-local things, and they determine kind of what this quantum theory of space-time could be. And that what, to me, would define, well, if you ask me for the essence of space-time, that is it, maybe. We can still talk about in the quantum theory, which has new elements and different unexpected ways of behaving, but we're still kind of, when we zoom out, we recognize, okay, here are observables that, actually I can compute classically, and I see that my quantum theory has a classical limit that reproduces them. So that's good. But I think there are overblown expectations to what detail a quantum theory could reproduce. And the nature of the observables is very special, and it's like no other theory we know of in diffeomorphic invariant geometry. So what is the mathematics that describes this? It's in part already there, I would say. So one is geometry of metric spaces beyond smooth. So that's an independent area, mostly in the Riemannian domain, it should be said, that mathematicians have been studying for 20 years, and it's actually quite a hot topic. So how do we define, especially for instance, how do you define curvature or Ricci curvature on such spaces? So that's generalized, so you still know what distance is, so you still can ask many metric questions, but the smoothness is not needed. So that's very interesting, and then more on the quantum side, if you combine that with techniques people call now random geometry, that is a certain way to generate superpositions of spaces or space-times, that is already something that has produced in 2 dimensions, very concrete examples, which maybe you philosophers should look at. You always need, concrete examples. For instance, in 2 dimensions and Euclidean, random geometry means you're taking a superposition over all spaces you can assemble from identical building blocks into piecewise flat manifolds. So that's a very simple thing. It has metrics, you can even define geodesics, you can define volume, you can define length. But then if you look at the superposition and you take a non-trivial continuum limit, what emerges in a very literal sense of emergence is a 2-dimensional continuum theory of geometry, which has totally different properties. Its geodesic, has certain scaling properties, its volumes, etc. And they're not canonical, so not what you expect like from a 2-dimensional theory. But this is a subject that is being studied by mathematicians. So it's a very, very big thing. So there is something rather than nothing, definitely, and something for quantum gravity to learn and to say, okay, here is some real mathematics to back up, our ideas of going beyond G mu nu. So here are some concrete ideas. So I'm afraid it's not topology, but that's
thanks.
That's difficult.
Thanks. That's helpful. I want to say something on the emergence problem. Right. So emergence is a very notorious notion, of course, and it's partly for that reason we kind of put that to the side and just focus on the space-time one. However, there might be a way to, if you have a certain understanding of emergence, that this may also help you to solve the problem of defining what space-time is. And this kind of also connects to your point, that if you have a certain understanding of emergence that brings with it some sufficiently robust understanding of the spatial temporal, then the picture may be different, and you can actually argue against also our view on this basis. But for most part, I think it is independent. For most part, I think you can leave aside that there is lots of debate on emergence and focus on the space-time thing, and then these case studies that would be very helpful.
So what you say? So there is, especially what I call random geometry, there is a well-defined notion of emergence, which is the statistical physics notion of emergence. I have microscopic building blocks. I look at the ensemble of those, and then on larger scales, the system, has certain properties that I could not have guessed. Where the dynamics, the dynamics of the microscopic building blocks generates certain aspects that I couldn't have anticipated from the micro state. So that's a perfectly good sense of emergence, and in certain then you come to things like universality. The actually independence of whether the little building blocks were green or blue or red. It doesn't care. In microscopic
You basically spelled out in one particular example of the definition by Butterfield. So in novelty, you have some novel property that you would not have seen in the starting point,
Yeah.
and then there is some robustness on the changes of the starting point, and then you need the limits, approximations, and that is.
Well, that part of it is in agreement. But I mean, it is a statistical mechanics view of things, so it's not a radically new thing. Just apply to quantum gravity.
Yeah. Yeah, and I think it's probably also helpful to have this very concrete statistical notion, because in the philosophical debate, philosophical notion, you then already start the debate on what do you mean precisely by novelty, what do you mean precisely by dependence, what do you mean precisely by robustness, and so on and so forth. And that was what I meant, that if you have some argument, some proposal for what exactly that could mean that implies a certain understanding of the spatial pole, then this might also help you to address this issue. But I think this one would be different then. But it may be helpful to understand the emergence and space-time emergence probably, yeah.
Right, so then we have Richard.
My point has already been made.
Okay, then Magda.
Was it critical or was it supportive?
Basically, Chris
Yeah, thanks very much. I sympathize with the general issue behind, so the idea that like we have to be more precise when we talk about space-time emergence in philosophy, especially. I'm a bit worried though about the level of specificity that like this framework seems to suggest.
Yeah.
In the sense that like somehow close to what Jess was saying, like if you want philosopher to to achieve the level of specificity that like physicists are dealing with, then like they would probably just try and fail to do physics basically. So I mean at a certain point you claim that you still have some room for theory independent investigation within your framework. But I guess I don't see how does it work, and like so if you can expand a bit on that and like what you mean maybe with theory independent.
Yeah, very good point. Yeah, I think it really depends on so we Rasmus and I may argue differently now. So I think Rasmus would be quite sympathetic, for example, for the reasons you gave earlier, to say, well, actually, we should do basically physics, and there's not so much to do left to do for metaphysicians. I would disagree with that. I would think that there is still lots of work to do, and a way to make sense of it is that the specificity, I think, should look for what is fruitful for certain aims, and the aims or the topics, say, in metaphysics are usually different than the topics in physics. So for addressing certain metaphysical problems, we will usually need a different level of specificity. So maybe a more abstract level, but less abstract than just saying space-time. And what I meant was because, so you could think that we have different theories of quantum gravity, and now we look at each theory, and then we make claims about whether space-time or something else is fundamental or not. And then we go to the next theory and do this, and so on and so forth. And you have always this theory latedness there. You cannot say anything that spans or goes across the different theories. And I think this is not the case precisely because the theories are different because they are talking about different spatial temporal aspects. That's the broader picture. And this is useful for us as metaphysicians. And this is useful. We can work with that. That's fine. That's a level of abstraction that is fine. And then maybe you can additionally worry whether you need to be very specific in terms of, for example, what kind of dimensionality you're talking about, and so on and so forth. What kind of metric structure you're talking about. And usually, whether it is helpful or not depends then on what you need to hold fixed, as Baptiste was pointing out, I think. Because if you look at a certain subclass of theories that have emergent non-fundamental metric structure, and you want to make further distinction within this kind of subspace, then you need to be more specific than just saying, well, I have non-fundamental metric structure, because you're already holding this as a given in a sense, and now you look for differences in within that subspace. But if you are concerned with something else, then it may be fine to say, well, metric is non-fundamental, by the way, but it doesn't really apply to what I'm looking at now. So I don't need this additional specificity of what kind of metric structure, Lorentzian, what have you, this actually is, and so on. So I think you can have this level that philosophers need to not become physicists, because the issue is always about certain features of space-time that can be expressed in terms of spatial and polar aspects, as we call it. Yeah.
But like, how's that theory independent? Like,
yeah, because I mean, maybe it's not. Maybe for some theories it doesn't work. Some spatial and polar aspects cannot be adjusted to a certain mathematical framework. That might be possible, of course, yes. But in general, we can talk about. For example, there are various theories that have a fundamental metric, but the metric is different in those theories. Yeah. And so we can have some abstraction. Yeah.
Thanks.
Yeah.
So then we have Joanna.
Thank you. That will be, I think, a rather minor point. You had that table with those rows, right? That was one of the places where one could have an impression that you presuppose that those various aspects or features of space-time are totally independent of each other, so we can do the combinatorics and as you have in the table, but that clearly isn't the case.
Yeah.
For example, like metric and metric signature are related, or Lorentz invariance and Lorentz signature, and so on. So I just wonder how taking into account those relationships would change your overall account.
Yeah, completely correct, yes. So this is a simplified picture in this very sense you said. I think it might complicate things. It definitely complicates things, yes. However, I mean, this is not meant as ordering actual theories in terms of now we have general relativity, now we take something away, then we have theory A, then we take something away, then we have theory B, and so on and so forth. It's really just about focusing on there are certain things missing and deliberately abstracting away from these interconnections between the things to make this point. If you're then talking about concrete proposals that deal with a fundamental space-time split or a fundamental metric or emergent signature and so on, then this will be very difficult, of course, to take care of. And what exactly are the implications? I completely agree. But so this table is purely for it's hypothetical theories, right? It's purely for an alternative way to make sense of what we are proposing in terms of these different concepts and concepts of space-time and how we can make sense of the different problems that arise here. Yeah, I fully agree that this is more problematic. Yeah.
Okay, so last question, if I missed someone, is Daniele.
I don't think it's necessary.
Okay. Are there other questions from the audience?
Yeah, can I ask about the table?
Yeah.
So it's not, they don't need, these needn't be mutually exclusive categories in the sense that, you know, once I start computing, you know, what I call observables or what may even be phenomenology, they may give rise to the same answers.
Yeah, exactly. Yeah, exactly. And definitely. You can have theories that are, or classes of theories that move between the different rows here and so on. Yeah, definitely. It's really just for illustrative purposes. You shouldn't read any theories in there or observables or something. Yeah.
All right, we still have a couple of minutes